All right, Trig lecture 421, 422. Student will find the area of a triangle using Heron's formula. This is a review. We've done this before, just a little walk down memory lane. We use this when we know the sides of a triangle and we don't know the height of the triangle. Otherwise, we could just use area as 1/2 the base times the height. If we don't know the height, we can go ahead and use Heron's formula. Here's how it works. Heron's formula is this. Will give us the area of the triangle as long as S is the perimeter of the triangle divided by 2. So the half of the perimeter we're going to call S, and then A, B, and C are going to be the sides of the triangle. And of course it doesn't have to be called A, B, and C. We could call this Q, R, S, and these would be little q, little r, little s. But here's one instance of it. So we take half the perimeter, put it here, 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 and here, and the sides of the triangle, here, here, and here, and we try not to mess up our arithmetic. So here we go. Use Heron's formula to find the area of each triangle, round to the nearest tenth. So I'm going to find S first. We got 6 plus 14 plus 14, well that's 20, is that 34 over 2? So S is 17 yards. We'll put the unit of measure when we get done. And now I'm ready to use my formula. I was going to say that the area is the square root of S. I'll go ahead and write it for you. S times S minus A times S minus B times S minus C, where A, B, and C are the length of the triangle. Here it's going to be X, Y, and Z, but it's just the length of the sides of the triangle. So here we go. It doesn't have to be A, B, and C, it's just the sides of the triangle. S I just found was 17. Hopefully I did my arithmetic correctly. S minus A would be 17 minus 6. 17 minus 14. 17 minus another 14. That's isosceles. It doesn't look like it. My drawing isn't very good. And then we perform this operation with our calculator and round to the nearest tenth, because that's what we were asked to do. So let's see what we get. Where's my calculator? I got 41.0. And that would be square units, square yards. And that would be the area of that triangle if I haven't botched my arithmetic. And let me see if I can find my other key. Hey, this is it right here. What do you know? 41.0 square yards. Yay! All right, let's take a look at another one. Just the same thing. R, P, and Q. Could be A, B, C. It doesn't matter what the letters are. I'm going to find S. So S is 9 plus 16 plus 10.6. I'm going to take half of that. So I'll do that with my calculator. 9 plus 16 plus 10.6 equals, divided by 2 equals 17.8 is the value of S, if I haven't made an arithmetic mistake. And so now I'm ready to find the area. The area is the square root of S times S minus the length of one side times S minus the length of another side times S minus the length of a third side. Oops. Where that came from, I was thinking something and wrote the wrong thing. S is 17.8. Just goes to show you what happens when your brain gets old. 16. And I'm going to try to get that in my calculator. I think I'm going to simplify this a little bit for myself. I'll call this 17.8 times, I'll perform this operation. And I could do that in my head, but I don't trust my head anymore. 8.8. 17.8 times 10.6 minus 10.6 rather. See, I don't trust my head. 7.2, providing I haven't made an arithmetic mistake or typed in the wrong number. 17.8 minus 16, which should be 1.8, but the way I'm going right now, hey, it's 1.8, what do you know? I have a hard time trusting my old brain. That's a little bit easier to put in the calculator, so I'll go ahead and do it that way. Times 8.8 times 7.2 times 1.8. I want to take the square root of that, and that will give me 45.1, providing I haven't made a mistake. And that will be inches squared, square inches. And that is an approximation, and hopefully I haven't botched it. Did I use an approximation symbol up here? I did not. This is an approximation also. So let's see if I got it right. $45.1, yay! So there we are. I don't think I skipped any of them. That's a little walk down memory lane. My board seems to have frozen up. Well, now's a good time as any for it to freeze up. Oh, there we go. We used the Heron's formula to find the area of a triangle that didn't have the height shown. Here's Heron's triangle, and there's a couple of examples of it. If you've done this before, you can do it again.